Hello out there in internet world. Wanted to talk to you about the constant of integration, and to set that up, I just want to point out that there is a f prime function. This is a derivative 2x minus 1, and my instruction is to find f of x, the original function that resulted here. The only condition we know is that f of 0, the function that I don't know, has a y-intercept of 3. F of 0 is 3. But what we did before today's lesson was we would integrate a function. In this case, I'm integrating a derivative function, which will get me back to the original function. So I apply the integral with the appropriate notation and integrate 2x becomes x squared, and the integral of negative 1 becomes negative x, and that's where we add the plus c. That's what we did last week, and that's the basis of just your standard regular general integral. It's called an indefinite integral. Anyway, I know that f of 0 equals 3, which is going to tell me some information about my c value. If some of you are clever enough, you'll see that c is equal to 3 just from that information alone. But to prove it, I got my new f of x, which is the integral of f prime of x, which equals x squared minus x plus c. I know that f of 0 equals 3. So I put in 0 for each of the x's, and then I have the c is the unknown, and then 3 is the final result. So in other words, 0 plus c equals c, and c equals 3. Therefore, f of x, the function that goes through 0, 3, and has a derivative of 2x minus 1, is going to be x squared minus x plus 3. Now, in order to check this, the first thing you want to do is put in your answer and find out if that function goes through the point 0, 3. So I type in f of x equals x squared minus 2x plus 3, and I get that. The second thing I want to do is to make sure that the derivative of my answer is the given function. And so I take the derivative of f of x, and I also take the line 2x minus 1, which was given, and I want to make sure that f prime of x and 2x minus 1 are in fact the same, which they do. They match up as this line here, which would be y equals 2x minus 1. So to study another example, it's just a simple polynomial, again, quadratic. I first am going to take the integral of the derivative to get back to f of x. So f of x is equal to the integral of the derivative of f of x, and I do my standard integration, and I get the plus c, which says there's a constant. Again, if I took the derivative of this function, the derivative of c would be 0. So I don't know what c was, I just know its derivative was 0, which is why there's a 0 here. Now what I do is, once I have that, I take the given information, f of 2 is equal to 5, and I put 2 in for x here and here, and I leave the c, and I know that the net result is going to be 5. So 5 equals 12 plus, 8 plus 4 is 12 plus c, and I subtract 12 from both sides, and I get c equals negative 7. So the function I was looking for that contains the point 2,5 is x cubed plus x squared minus 7. I put that into the graphing calculator and observe that my function does in fact go through the point 2,5. I can use this notation here to do that. I make a coordinate of a point, 2 comma f of 2, and then I'll show that 2,5 is on my graph. And furthermore, I take the derivative of f of x, and my statement that 3x squared plus 2x, I want to make sure that the derivative of my answer matches the given derivative, and that's shown here. Finally, for one last example, we throw in some ugliness like an e to the x and this 1 over the square root of x, just to remind you about some integral processes. For the integral of e to the x, that's e to the x, thank you. And then here we raise the power by 1, so negative a half plus 1 is 1/2, and then I divide by a half, which is multiplied by 2. So that's the function with the unknown constant. My given information says f of 1 equals 1, so I make y equal to 1, I make x equal to 1, and I learn that e plus 2 plus 1, or plus c rather, is equal to 1. So to find the value of c, I'm just going to subtract e and 2 from both sides. Not many of you probably go to a calculator here, but negative e minus 1 is the exact value for c, and so I'm going to put that in as my c value instead of a decimal. That way I'll get a truer form of my answer. I also put the 1/2 power back into radical form, and I check using the exact same technique. So just to make sure, pause the screen at some point so you can see all the things that you want to enter to make sure that you're checking on Desmos correctly. And don't forget, in your work, include the Desmos screenshots to verify that the work you're doing is valid. When you do that, please make sure your Desmos screenshots have the same information as mine. Thank you very much for watching, and have a great day.